Hi friends, I am Amit Kumar. Welcome to Technical Education Classes, and today we will discuss about recording formats and methods. यदि अभी तक आपने इस चैनल को सब्सक्राइब नहीं किया है तो सब्सक्राइब कर लें ताकि लगातार आपको अपडेट्स मिलते रहें। साथ ही अपने साथियों के साथ शेयर भी करें और लाइक भी करें। बेल आइकन प्रेस कर लें ताकि रेगुलर अपडेट्स की जानकारी आपको मिलती रहे। थैंक यू। A recording format is a format for encoding data for storage on storage medium. रिकॉर्डिंग फॉर्मेट्स में हम लोग हमारे पास जो अवेलेबल डेटा होता है उसे हम लोग इनकोड करते हैं, उसके बाद उसे स्टोरेज मीडियम में स्टोर करते हैं जिसे हम लोग रिकॉर्डिंग कहते हैं। मल्टीपल लेवल्स ऑफ encoding may be achieved in one format. For example, a text encode page may contain HTML and XML encoding combined in a plain text file format using either EBC, DIC or ASCII character encoding on a UDF digitally formatted disk. In electronic media, the primary format is the encoding that requires hardware to interpret, that is, decode the data, while secondary encoding is interpreted by secondary signal processing methods, usually computer software. Magnetic recording is the storage of data on a magnetized medium. Magnetic storage uses different patterns of magnetization in magnetizable material to store data and is a form of non-volatile memory. The information is accessed using one or more read-write heads. Now we will discuss about recording methods. Recording methods vary from device to device. Following are the magnetic recording methods. There are four recording methods. They are heat assisted magnetic recording HAMR. Second is longitudinal magnetic recording LMR. Third is perpendicular magnetic recording PMR, and fourth one is shingle magnetic recording, that is SMR. So first is heat assisted magnetic recording HAMR. Heat assisted magnetic recording is a magnetic storage technology for greatly increasing the amount of data that can be stored on a magnetic device such as a hard disk drive by temporarily heating the disk material during writing, which makes it much more receptive to magnetic effects and allows writing to much smaller regions and much higher levels of data on a disk. As you saw in the given figure, the region being written must be heated in a teeny area small enough that diffraction prevents the use of normal laser focused heating and require a heating, writing and cooling cycle of less than 1 nanosecond, while also controlling the effects of repeated spot heating on the drive plotters. The drive to head contact that the adjacent magnetic data which must not be affected. These challenges required the development of nanoscale surface plasmons, that is surface guided laser, instead of direct laser beam heat. New type of glass plotters and heat control coating that tolerate rapid spot heating without affecting the contact with the recording head or nearby data. As you can see in this picture, that is HAMR recording system. New methods to mount the heating laser onto the drive head and a wide range of other technical development and control issues that needed to be overcome. HAMR drives have the same form factor such as size and layout as existing traditional hard drives and do not require any change to the computer or other device they are installed into. They can be used identically to existing hard drives. Advantages of HAMR system. First one, can be used to make many types of patterns. Second, useful for magnetic recording, checkered pattern for micro and nanoscale levitation purpose. Third, cheap as the laser used typically consumes low power. Fourth, can be easily implemented. Fifth, can be used for very fine details depending on the skill with which the laser is used. Apart from the given advantages, some disadvantages also in the HAMR system. These are potential loss of magnetization, super paramagnetic nature of ferromagnets at very small size limits how small one can go. Third, boundary issues due to undetermined possibilities at the reversal junction. Fourth one is depth of reversal is currently limited. Fifth, not too efficient on substrate as silicon acts like a heat sink, better on glass substrate. Last one is residual magnetization is a problem due to the depth of reversal which is limited by the penetration depth of the laser beam. Our second recording method is LMR, that is longitudinal magnetic recording. In longitudinal magnetic recording method, each data bit is aligned horizontally in relation to the driver's spinning plotter. In longitudinal recording, the fields between the two adjacent bits with opposing magnetization are separated by a transition region as shown in the figure. While our real densities have historically pretty much doubled every year, more recently, however, the rate of increase has slowed, and the limit of areal densities for hard disk technology using longitudinal recording due to the super paramagnetic effect is now generally reckoned to be in the region of 100 to 200 gigabits per inch square. This has led to more aggressive approaches to delaying the super paramagnetic effect being sought and the emergence of perpendicular magnetic recording, that is PMR technology, as a solution capable of doubling hard disk data densities in the relative short term and of ultimately enabling a more tenfold increase in storage capacity over today's technology. Our next type of recording is perpendicular magnetic recording, that is PMR. Perpendicular recording or perpendicular magnetic recording, that is PMR, is a technology for data recording on hard disk. Perpendicular recording can deliver more than 3 times the storage density of traditional longitudinal recording. For decades, the hard drive industry has focused almost exclusively on a method called longitudinal magnetic recording to record data on hard drives. In longitudinal recording, the magnetization of each data bit, that is the binary digits 0 or 1, is aligned horizontally parallel to the disk that spins inside the hard drive. In perpendicular magnetic recording, that is PMR, the magnetization of each data bit is aligned vertically to the spinning disk, providing the ability to store more data on a given disk than is possible with conventional longitudinal recording. The problem with using this method is that we are rapidly approaching the point where the microscopic magnetic grains on the disk are so tiny that they could start to interfere with one another, thus losing their ability to hold their magnetic orientations. The resulting data corruption could render a hard drive unreliable and thus unusable. This phenomenon is known as the superparamagnetic effect, that is SPE. In perpendicular recording, as shown in the figure, the adjacent bits attract instead of repel, creating more thermally stable bits. In addition, the media contains a magnetically soft underlayer, that is SUL, beneath the recording layer. This SUL allows a large effective write field, thus higher corrosivity media, enabling further increasing density. Lastly, because of the vertical orientation of bits, the PMR recording layer tends to be thicker than that used for longitudinal recording, providing an increased signal for the read heads. The recording head for perpendicular recording consists of a single pole inductive write head with a suitable flux return path designed for high efficiency, low strip field sensitivity, and sharp field gradient capable of writing on perpendicular media with corrosivities. In perpendicular recording, the media is deposited on a soft magnetic underlayer that functions as part of the write field and effectively produces an image of the recording head that doubles the recording field, thus enabling one to record bits at a higher density than longitudinal recording. Our final recording type is shingled magnetic recording, that is SMR. It is a new hard drive technology that allows that tracks on a plotter to be layered on top of each other just like roof shingle on a house to increase plotter density or tracks per inch, that is TPI. Current technology perpendicular magnetic recording, that is PMR, uses a parallel track layout. By increasing TPI with SMR technology and decreasing the space between tracks, SMR offers tremendous potential for overall hard drive capacity gains. The end product physically looks and feel like a standard PMR drive with higher capacity in the same physical footprint. However, the architecture change means the user experience from a performance perspective will be dramatically different. Thank you for watching.